today we're going to talk a little bit more about how to use your graphical calculator to do scatter graphs. This one takes a little bit more kind of the general functions of the calculator. So I'll just kind of talk you through an example. So if you see down below me, I've got the scatter graph question from the winter exam. So underneath me, I've got the table, and then in the bottom left is kind of what you do with the table. I've skipped part B because that's basically where you draw the graph and look at the correlation, which we can obviously just talk about, and most of us tended to be okay with that, but part C was the bit where we tended to struggle. So when you've got a scatter graphs question, okay, and I've just put a couple of notes in here, things to remember. First of all, you're going to need 3 parts. So a table, a data and statistics graph, not just a normal graph, but number 5, data and statistics, and a calculator. And if you label your variables, which I'll show you how to do in a second, it makes it easier. And finally, just keep everything on the default. So it's good. When you do the regression line, it will default to F1. Just don't try and change too much, just keep it simple. So first thing we want to do is set up our pages. So you can see obviously on here we got obviously our new document. So first thing I'm going to do is make a little spreadsheet. So that's going to be lists and spreadsheets, and I'm going to make one like so. I'm also going to insert a data and statistics graph, which we're going to come back to in a minute, and then finally we're going to want a calculator page. Those are going to be the 3 pages we're going to use, and we're going to use them in that order. So first thing we're going to do is we're going to draw our table. Now down here we have the table, distance and population. So first thing I want to do is I need to input the data. There's no quick way of doing this. There's no sneaky trick. You need the data on the graph. I've double clicked on A. You can do that, double tap on your calculator, and I'm going to label this as distance because that I want to be my first axis. The next thing is the population density, so I'm just going to call it pop dense, just so I know which one it is. And then I'm going to enter the data. So obviously I can see distance, the first one is 0.8. And then this is, like I said, there's no quick way of doing it. You've just got to kind of churn through the numbers. But once you've typed them in once, okay, they'll be on the graph. Now what you can hopefully see as I'm putting these on next to me here is that it's actually plotting them on the graph. So it doesn't have a height yet because we haven't put in the y values, but this is automatically putting in the distance as the x-axis as far as I'm aware. Yeah, so where are we up to? 2.8, 4.6, 3.7, 1.9 and 5.1. It doesn't matter if you do them like as pairs or if you do I like to do one column and then the next, but it doesn't really matter. 5600, 5800, 3600, 4500, 2800, 3300, 1100, 2300, 700, 800. So now hopefully we can all see that we have now got the values in the table here. And I'll show you in a second how we can do some stuff with this. Now when we go to this graph here, what we can now do, it's got the kind of points roughly where they should be, but it's not perfect. What we now want to do is where it says click to add variables. So I want to have population density, and when you click on this here, it gives me the option. I want population density on this, and I want, it should, although it probably hasn't, so we just kind of scroll down. Oh, no, don't do that. Okay, and population density can go on the y and distance on the x. And you can see it automatically changes the scale. And now we can now see where the points are plotted. Now you have to do this by hand, the points onto when you had this question. But if you're not sure where they should go, obviously it tells you on the graph there. And make sure that obviously you've got the right things on the right axes. Now there's 2 ways you can do the linear regression line, which is what you're going to need. It says calculate the equation of the regression line in the form P equals MD plus C. But now when you do this on your calculator, you can do it in 2 ways. First of all is you can select all the points with a box, like so. So I select all the points, okay, and when you go onto your tools here, you should have some options. Now they're different to the options on the graph. Okay, you don't need all of them. You can see there's lots of different things we can do here, actions, but what we want to do is we want a regression line, because it says here regression line, and Now, it doesn't give you it in the same format as in the question. The question says MD plus C. So it's 2 letters plus 1 letter. Here it says MX plus B, but that's exactly the same thing. 2 letters and a letter. We click on this here, and it gives us the line. Y equals negative 967.354x plus 6297.82. Now, you don't need, obviously, all of that information. You'd probably give it to 3 significant figures. So you'd probably say something like minus 967x plus 6,298. But that gives you the line. It also gives you the equation. So that answer there is the answer to CII. So if I was going to go onto here, I could just type in, ooh, it's kind of gone a bit funny now. Probably shouldn't have done that, but it's okay. We'll live with it. I could add a little text box. That's tiny text. Let's make it a bit bigger so we can read it. Great video skills. So I'm just going to put that there, and I can say, okay, P equals, obviously we've got Y, they're saying P, but it's going to equal, and I'm going to say negative 967. And obviously it's not X because it's P and D instead of Y and X, but D for distance, D for density. So P equals minus 967D plus, and I'm just going to give it to, I don't know, 3 significant figures, 6300. So something like that would be fine. Now we've got this line, it says, use this equation to estimate the population density of a region 2.4 kilometers from the city centre. Now for most of your calculators, it's going to define this one here as F automatically. But for some of you it won't. So I'm just going to assume that it isn't. So what we do is we can go back to the initial graph. And what I'm going to do is I'm just going to select these values. Okay, so I'm just going to select the values I've got. It should, although saying that, you can actually do it without, and it should automatically do it. I go on to my functions, okay, and you can see again, it's got lots of options here. I'm going to do the linear regression line again on this graph here. Sorry, on this table. So it's going to give me that line, but in kind of table form. So again, I want the mx plus b, even though it's md plus c, because obviously p is y and d is x. I click on this here, and it's going to give me this table here. It all looks really confusing. Don't worry. We know that it says x list. All you need to do is say, well, what is x on my graph? Well, x on my graph, we know, is distance. That's the x-axis. What's on the y? It's population density. And that's all you need to do. Don't click on anything else. You'll notice it says save the regression equation to F1. Leave that as it is. I'll show you why in a second. Always leave it as F1. That should be the default. Don't change it. Click OK. Okay. And it's going to give you all these things here. Now you can see that's the M, that's the B from what we've just done down here. But you don't need to worry about all of this. What's important is it's now saved that line as F1. We can now use that in the calculator. So basically what it's saying is F1. F1 is like f of x. So I can work out fx for any value. The next question says, use this equation to estimate the population density of a region 2.4 kilometers. What it's asking is, what's the f of x when x is 2.4? So I can say f of x when x is 2.4. And we press enter, and it gives us the value, 3976.17. Again, we can round it. It says to estimate, so we wouldn't need an exact estimate. So I can say, oh, well, if that's that, I just want an estimate. Maybe 3980 would be close enough. Ooh, not there, here. So I could say 3980, and I can just pop that there. Now, the final question says, why would it not be sensible to use this equation to estimate the population density of a region 6.3 kilometers from the city centre? And there's lots of reasons for this. Now, the most obvious is when you look at the graph doesn't go to 6.3. That's the obvious answer. It's outside the range of your data. Your data only goes up to the highest is 5.1. So a simple answer, if you didn't want to do any graphical stuff, would just be to say it's off the graph. You could, if you wanted to, work out what it was. Again, we can use our f function. We want to do the f1, and I want to do 6.3, so I put in 6.3. And you can see it gives you a value of 203. Now, when you consider most of the values you've got are much higher than that, it's not a very good estimate. It's obviously a very low population density which implies it's probably not a city, so it's probably not a comparable city to the ones in there. But the best answer would be just very simply, it's not close to the range of values that you have. And that's pretty much scatter graphs and what you're going to need. So to review, put your table in, okay, type your values in, 1, 2 columns. Even though our table went across, you need to obviously have, columns. We can use the table so we can go on to statistics to find the regression line here, which is what we did to get these values here, saving it as F1. You can then plot it onto the graph by selecting all the points, and then it gives you the equation here. There is another way as well, which you can do, where you can just do it. You can right click on here, it's being a bit funny, and you can get it to select all points on some of them, but the easiest way is just to click them. Some calculators as well will allow you to do a function here. This one doesn't, to select all points. Easiest way, like I said, is just to select them all and then enter your regression line. Remember to use it in the right format. And then finally, you can use your F1 to estimate values from the linear regression line. Good. Have a go at some of these. I'm going to obviously share with you some other questions, some scatter graph questions. And like I said, scatter graphs, nice, easy, quick marks. The calculator does, just like the other ones, lots of the work for you. And just remember to set up your 3 pages and use them properly.